Hello, my name is László Tolnai. I'm responsible for the Micred unit inside Siemens. We are part of the Simcenter family and we create measurement instruments for thermal transient testing of electronics. This specific product delivers that laboratory test to shop floor environments to validate the thermal performance of electronics, which is vital for power electronics and electrical vehicle industries. Any measurement results gained from the close-to-manufacturing environment is directly comparable to measurements previously done at earlier phases of design, measurements used for calibrating thermal models for simulation, or measurements used for capturing thermal degradation. So the specialty of this specific form of thermal transient measurement is maybe two- or threefold. In general, what we call quality tester, that includes a set of features as such. One is an automated measurement, which is predefined by engineers, but the actual performance of the measurement does not require engineering skills. It can be done by technicians, it can be done by an automation. So that's one of the functionalities. The other functionality that when we talk about quality testing or verification testing, these testers can get integrated to output the measurement data to a central storage for further processing. So that's the second thing. And the third thing is that these devices are capable of evaluation of the measurement results itself in an automated fashion. Indeed, these stress testers make thermal transient tests available in a more democratic form. One is using the tests not just for validating the actual product that is manufactured, but also validating or reiterating manufacturing processes and process changes, be it change of a material, change of a manufacturing time, change of a setting of a line, and that can also be validated immediately on the shop floor in a way that it's comparable with the initial design targets. The object at hand here is a power inverter, so it's a full bridge consisting of multiple semiconductor devices in an assembly as it is used, for instance, in an inverter used in an electric vehicle. So let's take a look at how this works in real life. A measurement has been set up for an inverter module for all 6 positions, and that's stored here. And we start the measurement at a basic parameter to cool the batch. And we say OK, and we start the measurement here. And the parameters are saved, and the measurement is started. At the end of the measurement, you can see the transient curves for all the 6 positions, and it's listed that one of them is an outlier, so it's not meeting the initial criteria preset. So this way we know that this sample is not good. Maybe it requires further analysis, maybe it requires rework, maybe it's waste. And also these measurement results can be stored centrally, automatically, for further review and evaluation by engineers to run simulations on them or use that for statistical analysis. So as a summary, this quality tester delivers a laboratory-type twister test in a shop floor environment in a fully automated way with one click from start till evaluation and automatic storage of data. And it does that for a full bridge module, a full inverter, which is relevant for the power electronics and electric vehicle industries. Thank you very much for your attention.